Hi Joe, Mel here, speaking to you from sunny Norfolk at the moment where I'm on holiday, and I've just got a few moments. I'll give you a little demonstration on equatorial mounts. This little AstroTrack 360 is what I take away on holiday, and I use it to just take wide field star pictures and maybe a few close-ups. It has one rotation of axis, it's just the RA tracking. And as a demonstration, if I'm looking north and I'm following stars, this mount is rotating in an anti-clockwise direction. And you're quite correct, it's all down to viewpoint. If I now go to the north side of the mount and look south, the mount now appears to be travelling in a clockwise direction, as it would if it was following the stars. So I'm totally in agreement about you there, about the rotation of the stars is all down to your viewpoint. However, there is a conundrum that the equatorial mount gives to your flat earth model that I will now go on to explain. Okay Joe, I've now swapped the scopes over and I've got a small refractor mounted on the AstroTrack mount. The same mount with a single motion that's going to track the stars all through the night. Just like your ETX mount that you mentioned in your little repair video, the declination, tipping the scope up and down, is irrelevant. That could be hot glued into place. You just need the one rotational axis to track the stars. This mount pointing to the north, and I've set it at approximately 45 degrees, which is, I believe, your latitude where you are in America. The scope is pointing up at an angle of about 30 degrees because I'd like you to try and observe Saturn for me. If you go out at about sunset, you should see Saturn rising in the southeast. Set your mount running and it should perfectly track it up the sky, over due south when it's about 30 degrees up, follow it down, and then it will set in the southwest. Probably around about time the sun breaks and it's the next day. Off you go to bed, happy as Larry. You can go out the next day and you can set your mount up, watch Saturn rise, track it across the sky just with this simple mechanical single motion, and watch Saturn set. But this is the conundrum, Joe. This is a single mechanical motion that tracks the stars. If we leave this mount running, and so we watch Saturn go down and set in the southwest, the scope is still pointing at it. We leave it running, The middle of the next day, look where that telescope is pointing. It's still pointing at Saturn. Saturn is now 60 degrees down through the Earth. There's no magical refraction going to bring that up to the northern horizon. Saturn is 30 degrees down in the Earth. You can leave this mount running, and the sun crosses the sky and sets in the west. The telescope has swung around to the east, and lo and behold, there is Saturn again, rising beautifully up the sky, tracking it absolutely perfectly. Saturn sets in the southwest as the sun rises, but the mount keeps running. The mount still keeps tracking Saturn. Look, this is a slight problem for the flat Earth model. No problem for the globe one, that's where we expect it to be. This is a simple one-axis mechanical motion. How come Saturn is down through the centre of the Earth, Joe? A nice little one for you to try and think about and explain, but I hope you've enjoyed it. Anyway, this is Mel signing off. Hope to see you again soon, Joe. Enjoy your videos.